So these are all exponential equations, right? The variables in the exponent position. That's the basic way of telling. So one way of graphing these without a graphing calculator is to just get an idea of what they're going to look like by plugging in some values. So if you plug in x equals 0 into this one, you should get out y is 1. But it's different than this one down here. If you plug in x equals 0 here, look, the negative sign happens after the exponent. This would mean that if you plug in x equals 0, you'd get 1 if it was written like this. Because the negative sign isn't in a parentheses and then raised to an exponent, that means you get negative 1 for this one. So that can help us spot some graphs. Let's see if the y-intercept is different for any of the other ones. If you plug in 0 here, you get out negative 1. If you plug in 0 here, you get out something different. You get out, no, wait. Yeah, you get out 2 for this one. If you plug in 0 here, you also get out 2. And if you plug in 0 here, you get out 1. Okay, so that doesn't narrow them down. There's 2 that have a y-intercept of 2. There's 2 that have a y-intercept of negative 1. There's 2 that have a y-intercept of 1. But at least, we've got one data point. Maybe we can further break it down. If you plug in 1, you should be at y is 1/2 for this function, right? I don't think you're going to have 1/2 in any of these other ones. Maybe you will, though, because of the negative exponents. I'd have to think about that. Yeah, because this one, if you plug in 1 here, this is negative 2 to the negative first power. So this is negative 2 to the negative first. That's the same thing as negative 1/2. Because a negative first power means that it's the reciprocal. So if it was 2 to the negative second, then it'd be 1 over 2 squared, right? So this is 2 to the negative first, so that's 1 over 2. So this one isn't 1/2, it's negative 1/2. If I plug in 1 in here, I've got 2.5 to the negative 1/2 power. That's just going to be something yucky. That's 1 over 2.5 plus 1. So, cheating a little bit, that's 0.4. So that's 1.4 here for when you plug in x equals 1. If you plug in x equals 1 here, then you've got negative 1.5 to the negative first power. So this is negative 1 over 1.5. So it's negative 1 over 3/2. So that's negative 2/3, I think. I did that pretty quick, though. Let me see. 1.5 to the negative first power. Yep, 2/3, and then the negative sign. So negative 2/3. If you plug in 1 here, that's 3 to the negative first, so that's negative 1/3 plus 1, so that's also 2/3. Oh, but that's a positive 2/3 and a negative 2/3. If you plug in 0 here, no, sorry, if you plug in 1 here, you get 1/2. Oh, we weren't able to narrow this one down because there's another one with a y-coordinate of 1/2 when x equals 1. We've got 2 negative 1/2s. Wait, no. This is negative 1/2. This is 1.4. So maybe we've got it here. Maybe we've got one of them eliminated. So that's one way of approaching these. The other way of approaching these is by understanding how exponents work. Okay. So if it's a 1/2 power, that means it's going to be declining as we read it from left to right. And the reason for that is because you're multiplying every term by 1/2. It's to the power of x. So you could be doing 1/2 to the third. That's 1/2 times 1/2 times 1/2. If the exponent, call it b, is between 0 and 1, we should be seeing a graph that declines like this from left to right. So this is a 1/2 power. It should be going down like this one or this one or this one or this one. So there's 4 options there. Should be decreasing over time. And from those options, we know 0, 1 has to be a dot. This one's got it, this one's got it. This one does not have it, this one does not have it. So that eliminates these two when we're considering just this equation. If we plug in x equals 1, then we should have 1/2. So this one's possible, and this one's possible. Still haven't eliminated. Those actually look like the same graph. I'm trying to make them different than what's in the textbook. I can't really distinguish. So here, graph 1 either goes with this one or this one. Okay, and we can do the same thing for the other ones. Y equals negative, we'll call this graph 2. Y equals negative 2 to the negative x power. So the negative sign here, like if you have x the graph of x squared, it's a parabola, right? If you multiply everything after the x squared by -1, then you flipped it. It's opening down like this. Okay, so same thing with a -2. Instead of being, so if it was y to the 2, oh, but that's a negative x, shoot. That's going to mess everything up. So that's the same thing as -1 over 2 to the x. You can make that exponent be positive by putting it in the denominator of a fraction. So it's the same thing as -1/2 to the x power. Right, because the exponent of x could come on top of both these and get the same thing. Is there anything that matches that here? Not quite. Okay, so it's hard to do these without a calculator, but we can do it. It just, I feel like I'm pushing us too far, like I'm going way too fast with all this stuff, because there's a whole bunch of little details about, what happens when you multiply by a negative sign that I don't know if we're all on the same page on like this. But what I've done here is I've rearranged this one so that it's -1/2 to the x, and now we can use that same rule we just used on this one. If it's a 1/2 power, it means it should be going down from left to right. But if you're multiplying it by a negative on the outside, that means we should be flipping it, just like we flip this according to the x-axis. Right? It's a mirror image on the x-axis. Okay, so that means we're looking for a graph like this that I just drew, which could be this one, and or it could be this one over here. What's the difference? They both have a y-intercept of -1. So because I made up these problems, they look like they're identical graphs, maybe a little bit off. This is -1, -2, -1, -2. Oh, so there's a difference. We should be able to plug in -1 and get out -2 on the y-axis, so we should have a dot there. So maybe that can help us rule one out. If I plug in -1 in here, -1 makes a +1, so 2 to the first power is 2, and now it's a -2. This one needs to cross at -1 on the x and -2 on the y, which is this graph for sure. Okay. Whew. What else should we do here? Okay, this one's done. We can just forget about this now. This one I'm trying to think. 2.5, what is that as a fraction? 5/2. And so if you got negative to the negative x power, you got 5/2 to the negative x power. That's the same thing as 2/5 to the x power, because a negative power means the reciprocal, right? And you could follow that logic too. You put it in the denominator of a fraction, and if you divide 1 by 5/2, you get 2/5. So this equation up here is the same thing as this equation down here. So there's that rule. We said the exponent is between 0 and 1, like we talked about earlier. So that means we should be seeing a declining graph like this. But the y-intercept is 1. It's bumped up 1. So this has a y-intercept of 1, and that has a declining graph. This has a y-intercept of 1, that has a decline. So it's either this one or this one. My graph 3 either fits with this one or this one. Are they different? I think I made the exact same graphs here. I must have typed something in wrong. -2 on the x, 4 on the y. -2 on the x, 4 on the y. I can't really find anything that distinguishes these two. They are kind of close. This is a 2/5, so that's 0.4. This is 0.5, so that's probably why those are close. So graph 1, graph 3 are done. It's either one of these two. It's just me being stupid and not distinguishing them enough. Okay, so down here we said, well, let's rewrite this as a fraction so we can use that fraction rule of exponents I was talking about. That's -3/2 to the negative x, and a negative x means it's a reciprocal, so we got 2/3 to the x power. Okay, so a negative sign flips it here. 2/3 means we should have a declining graph like this, but a negative sign means we flip it with respect to the x-axis. So we're looking for a graph that looks something like this. And so this is an option, and this is an option, but we already said that that has to be 2. So this graph number 4 that I'm labeling, it's got to be this one. We could check those points. 0 on the x, -1 on the y. We're good. 1 on the x, -2/3 on the y. That looks pretty close. And if we try to plug in -1, so 2/3 to the negative first power is 3/2 because it's a reciprocal, and it's -3/2. So -1, -3/2. That looks good. So we've got graph 4. That's this one down here. Okay. So one or the other for these. Use that rule about a negative exponent to the reciprocal. We know how this graph looks. It should be declining like this. And then this has a y-intercept of 1. Uh-oh. That's neither of these here. Maybe I didn't. I wonder what I typed that in Desmos. Okay, that's the last one I graphed. -2.5 to negative x plus 1. That's this one. Shoot. If you plug in 1, that should be 1/2. Nothing wrong there. Okay, one of these graphs I put in a y-intercept when I graphed it. But this graph of 2 to the negative x, that should look like 1/2 x, which is, oh, it's the same thing as this one, right? So this and this are the same thing when we rewrite it. And then we got 3 to the negative x plus 1, so y-intercept of 1, plug in 0, you get a y-intercept of 2. So that's this one or this one. And to choose between the two, it's 3 to the negative x, that's the same thing as 1/3 x plus 1. So if you go -1 on the x, the reciprocal of 1/3 is 3. 3 plus 1 is 4. So -1 on the x should have 1, 2, 3, 4 on the y. -1 on the x, 1, 2, 3, wait, 1, 2, 3. So this graph here, call it graph 5, has to match with this one. I think the book has chosen 6 graphs so that you can easily distinguish them. Yeah, because I'm looking at it now, it doesn't even have numbers. I messed up somewhere when I punched these in Desmos real fast, but